Hey guys, welcome to my channel. So today I got a little demo with my Bedini motor. This is the one that I sell on my website. I offer ceramic, which is in it right now, or neo. And for those of you that already have this motor, built into it is a spot for these optos. So you could turn this into an optically timed motor, how I have it set up right now. And this is the 8 for the 8 neo, and then this one has 6 for the 6 ceramic magnets. And yeah, so this is my typical little opto circuit. I have pulse width override right here, and then I have redesigned 3DP's pulse width modulator that's real nice. And yeah, this is Mosfet on switch, and then as usual I have the power coming in at red and black, and then output as yellow and white. This goes into my little cap dump. It's set at 14 volt trigger, so it triggers right around 14.8 or so. And these are 40,000, so 10,000 each capacitors at 35 volts. And then at the moment I have it hooked up to the lights, so go through the cap dump into the lights. These are 6 watt each LED lights, 12 volts. And then I'm just running off the power supply. So right now is about as low as it goes. I have it set up for 9 volts, and we're kind of going between 14 and 3, so averaging about 8 milliamps right now at this motor. And then on the scope you can see the pulse width modulation. So it's going about as slow as it could go. So let's figure this out. So we have 9 times 0.008 milliamps. So we're 0.072 watts right now is what we're running. And it takes about 17 seconds for the cap dump to charge up, and then it discharges into these lights for this low power. And yeah, it pulses, let's see, it's about 400 milliamp pulse at 15 volts. And yeah, it's running really efficient. So what I want to do now is disconnect this light bulb. So we're going to turn this off. We're going to hook this up to this battery so I don't keep getting blinded by this light. So this is a 3 amp hour 12 volt battery, just a regular lead acid or SLA sealed. Okay, so we'll turn this on. Let's get a little bump. So we're going to turn this back up to 12 volts, how it should be ran at. And at 12 volts, so now we're going into the battery. So we can see it charging up right here as it goes on up. So we're using 10 milliamps right now, and we're pulsing at 400 milliamps. So now we can start adjusting this thing. So let's bring this up. And before we do that, I should tell you this coil has a lot of turns. So this is 1,300 turns, 226 wires that are in parallel. And then I have the steel cores in them. So it's like this. So I have a whole bunch of different ones. This is a newer one. This is 24 and 26, 850 turns. And then this is 1,300 turns. Then my normal one is 475 with the 20 and 26. So I make all kinds of custom ones of these to try out. This was for one of my customers that wanted it like this, and yeah, it does really nice. So let's turn this thing up so we can get up to full power on this little guy. So you can see the scope. So it still has a little H wave in it, even with the optos, which is kind of cool. So we're using 115 milliamps at 12 volts, and here's our output. So we're basically a half an amp discharge going into this battery, and you can see how fast it charges now. So really smooth, really quiet, and the pulse width works really nice because you could just back this thing off You know, just a little pulse width goes from 100 to 50 milliamps, and it's still spinning really nice. And we could bring it all the way back down to use almost nothing, which is really neat. So yeah, pretty cool. So I'm going to be doing more experiments with the Neos and with this coil, with the 850. This one's really neat though. It just runs real quiet. Even at 100 milliamps, you're running that fan, you're about 650 RPMs, and yeah, you get a really nice return. So yeah. So don't forget to check out my store. If you guys need any of this custom stuff, I always make custom things for customers, and those of you that have this motor, we could send these out to you. Just let me know. Thanks for watching.